whenever we're at a particular spot. All right, so we're going to solve for v. I notice that all three of my terms have a 1/2, so those all cancel, because if I were to multiply by 2, they all cancel. They also all have the mass. As I divide by m, all of my masses cancel as well. Okay, so there's a lot of canceling. Let's rewrite, see what we have left. So omega squared x squared on the left, omega squared x squared on the right. I'm sorry, that was x naught squared. Do what I, or listen to what I do, not what I say. And then we got our v squared all alone over here. And we're just going to solve for v. So we're going to subtract that over. Okay, so omega squared x naught squared minus omega squared x squared. You don't have to write all of this stuff down. Just enjoy the show. Okay. I noticed that there is an omega squared in both, so I can factor that out. Okay, let's take it over here. Okay. So we got our omega squared times x naught squared minus x squared is equal to v squared. And then, of course, take the square root, right? So now, you guys all know that whenever we take a square root, the plus or minus is kind of understood, but we don't really write it a whole lot. In this case, it's actually really important that we include the plus or minus because this is a velocity function. Okay, so based on our position, and we're not done with this equation yet, but based on our position, we can find out how fast we're going. But it could be either going in the positive direction or going in the negative direction, even with the same position. Remember, as we look at a mass on a spring going backwards and forwards, oscillating like this, there will be a particular position where the object is moving this way and the object is moving that way. But regardless of whichever way it's going, its position determines its speed. So it's still going to be going the same speed as it goes this way, as well as it goes this way. So our plus or minus is important conceptually here because it could be going in the positive or the negative as it oscillates. So last but not least, so we've got our omega squared times our x naught squared minus x squared. And could we take the square root and cancel out that square? Yeah, but it doesn't cancel out these squares because the square isn't on the whole unit here, okay? So, but I can split it up. So my velocity function is going to be plus or minus omega times the square root of x naught squared minus x squared. And this is our last equation, which is the middle one in our box here at the bottom of the page. So, again, our speed here is based on the angular frequency, the rate of oscillation, the amplitude, and wherever we are. Okay? And based on where we are, if we're at the amplitude, what would be the speed? If we're at the amplitude?
Maximum?
It would be 0, because the x would be equal to x naught. X naught
right.
squared minus
Yeah.
x naught squared is 0.
Correct.
Which makes sense because as it reaches the amplitude, it stops before it turns back around. Yeah. And then if we find the maximum, so if we find our maximum, that occurs at the equilibrium point. And what would be our position at the equilibrium?
0.
0, yeah. So when x is 0, we plug that in and we solve it out and we can find our maximum velocity, which goes, or which it has as it goes through the equilibrium point. So let's wrap it up like a Christmas present here. So this is our velocity as a function of position. At the beginning of class, we learned about the velocity as a function of time equation. So we've got two equations that solve for the velocity. One is based on when it is, the other is based on where it is, which is cool. All right. And that's it. That's it.
You said you did it.
Well, no, I did not say that I didn't like this class.
What did you say?
I said I
This kid
like
sleeps.
the AP Physics C class the best of all of the classes that I've ever taught.
No,
But,
you took this class.
huh?
You said you took physics.
Well, so I did take one physics course in high school. It wasn't AP. I actually was in kind of a small town. We only had one high school, and it was like a regular high school with some AP courses, not as many as what we have at Paxson. And so I took like basically it was like a physics honors class. As a junior, most of the people in there were seniors because the track of the people, because I moved from another district, and so when I moved, then the order of things was kind of weird. So I took physics a year early. To be honest, like I got B's in it. Like I wasn't a stellar physics student. Even when I went to college and I majored in physics, I tried for A's, but most of my grades were like B's and C's, to be honest. And I really didn't get good at physics until I started teaching it. Because when you have to teach something, you really gotta know it and you gotta practice it. And at the beginning of my teaching career, I wrote out my notes and stuff and I followed it as I did my classes. I've been teaching for 2 decades now, so it's all up here now.
For 2 decades.
Yeah,
Imagine having to repeat
Yeah.
the same teacher.
and I'm still not tired of it.
It's
It's super fun.
looking real.
Yeah. But
That's how I feel
yeah.
about
So
basketball.
so I never took an AP physics course in high school.
I actually studied so like.
But in terms of teaching, yes, I had the most fun in my AP Physics C class whenever it does happen. Whenever I don't, I like this class the best, AP Physics 1.
Would you ever be?
IB Physics is fun, like year 2 stuff. It's still fun, but I really like the mechanics that we learned this year. Like, I don't get as excited for the topics that we do next year. Some of them I get excited, but a lot of these things I get really excited about because it's a lot of like the, real world stuff. I mean, technically it's all real world stuff, but a lot of the stuff that we talk about next year is like atomic physics and nuclear, which is cool, but it's not as cool as this stuff. I also really enjoy light. Light is fun to teach.
AP,
Yep.
right?
Yes.
Wait,
Jordan.
What's your favorite like physics theory? Like a theory like string theory or like other
Oh
stuff?
goodness, string theory.
No, not that specifically.
What's my favorite physics theory? So, remember that a theory is not necessarily something that has not been proven yet,
Yeah.
but rather a theory is the explanation behind the phenomenon.
Yeah, that's what I was
Okay.
That's exactly what I wanted.
I don't know if I have a favorite theory, to be honest.
Yeah.
Yeah. I'm not too sure.
I only reason I know some people have like a favorite theory because like it's one that they did so much research on or something. Because like it like intrigued them so much.
Yeah. Yeah. I mean, I like the mechanics stuff.
Yeah.
The rotation stuff, I have a lot of fun with too. Which we've done some rotational stuff, but there's more in store
Yeah.
for us before the end. Actually, I think we hit that first thing after the break.
How many lightning bolts have to hit me so I can get a flash?
I don't know.
I beg your pardon.
I'm not.
You gotta talk to the biology teacher first.
I definitely am lacking in my DC knowledge, so I don't even know how Flash got his powers.
Got hit by lightning.
Chemicals, no, there was lightning
He
and
got hit
chemicals.
by lightning? Okay.
And chemicals fell on him.
So
The
technically,
chemicals do.
lightning bolts carries
part of
anywhere
the
from 5 to
Oh, yeah.
25 coulombs of charge. I guess it depends on how big of a lightning bolt it was, and if there was any special circumstances, like was he surrounded by a particular, you know, metal that was high in concentration in the earth or something?
No, a particle accelerator made a lightning bolt.
No, the lightning bolt was, it was a lightning
Oh,
bolt.
No,
It's
there was
not
a
supposed
particle
to make
accelerator.
sense.
It was a
The particle accelerator.
Well,
They
I think
just won the lottery.
we're talking about Flash right now.
As far as I was
I was talking about actual.
But like,
Oh, actual, yeah, actually, most people who get struck by lightning actually survive.
well, that's
He
tough.
got
Like,
struck twice,
what'd you
and
do?
then won
I got
the
struck by
lottery
lightning.
twice.
Well,
That's
I was
so
supercharged. I was like an anime character.
I know.
Second.
No.
just because they're touching the ground doesn't really increase their chances of survival. It's really a matter of how much charge, how much electric current actually passes through the electrical impulse controlled pieces of your body, like your brain and your heart.
Is it?
Because if it doesn't pass through those things, then there's a good chance that you will survive. If it does pass through those things, it messes up the impulses that your brain and your heart work on, and it could kill you.
Some electrical will make you twitch your, like if you get shocked in a lot, or there's a, you get what I'm saying.
Yeah. Actually, we have it's called a TENS machine. It's these little stick-on paddles that you put on, not like the clear paddles.
Oh yeah, the muscle contractor
yes.
ones, yeah.
So
Oh
it's
my
like a
God,
muscle
that's
thing,
It's like the
and
period,
it basically
um,
sends an
simulated
electrical
thing.
current through your body, which there's
Oh.
warnings on it,
Related.
like not to have it on opposite sides of your body because the current could pass through your heart and mess it up.
Don't put it on your face either.
Yeah, don't put it on your face.
Brain
Or
stuff.
so like that.
Or
It
you can
does,
have like
yeah.
their shelter.
Yeah.
It
It's
feels,
either
it
become
feels
fried
good,
or
like,
you can collect their
where
shelter.
did I put it? I think I put it like
I would
right
love to
here.
Yeah.
see
Like, put it right here and here.
Huh? No, do it twice.
Yeah.
Okay, then you're
Can we
fried.
get to the Star Trek?
Star Trek versus Star Wars. Okay, so we're done officially with our lesson. So feel free to jump into those pods, or take a break first. But the pods are on the board, our screen. The quiz is up in focus already. So Star Trek versus Star Wars. Okay.
So it wasn't
Star Trek actually came first because Star Trek was originally
I know it's a negative.
a TV show. It ran for 3 seasons, I believe, in the
Oh, yeah, I have to
1960s.
close- I have to close my
And
eyes.
if you watch any of the original series of Star Trek, it looks really hokey
Don't use
because the technology back then, I mean, back then it was like cutting edge, like for real, like people were glued to their TVs and wondering what else will they actually do. They were also they had a very, they pushed a lot of the boundaries back then as well. Can you get the charger for the big trick? But the main difference between Star Trek and Star Wars is that Star Trek is more science fiction, where the science side of things is really front and center. Now, granted, there's still like great stories and relationships and things like that, because in order to keep the viewer's interest, you've got to tell stories. But a lot of it is more science, and then Star Wars is more science fantasy, where the story is really more important in Star Wars. Yes, they have spaceships and other cool things that we typically don't have, but that's the main difference. Star Wars actually didn't come out, the first movie came out in 1977. So this was a good 10 plus years after Star Trek came out. And back in the 80s, they had lots of sci-fi movies because people were interested in that kind of genre. A lot of them were not good. Star Wars actually was not expected to do as well as it did. In fact, they only expected to make 1 movie, but it did so well that they made sequels. And
Still making sequels to this.
yes, so but in terms of Star Trek, so Star Trek definitely has, it's more of a TV thing, Star Wars, at least originally, it was more of a movie thing, because Star Trek, it started off with the original series in the 60s, and then in the late 80s, early 90s, they kicked it off again with Star Trek: The Next Generation. That's